Let's begin this discussion of climate change with a race to see which countries are winning in the emissions of greenhouse gases. Okay, let's set the stage. It's 1850, the beginning of the Industrial Revolution. United Kingdom, England has a huge head start. They've got coal and looms and mechanization. United States, the former colony, is way behind. But as we move into the next century, we see the U.S. adopting the same coal and industrial revolution techniques. Germany, France, Belgium, the other nations in Europe are similarly gaining ground. United Kingdom is falling backwards. The United States takes over at the dawn of the 20th century and becomes an industrial powerhouse. Just ahead, we see obstacles: World War I, the Great Depression, the Spanish flu, World War II, big disruptions, shaking everything up. England falls further behind. Germany takes over as a second-place leader. World War II, we lose Germany after the end of World War II. Now it's the Cold War. The USSR is gaining ground. Back and forth we go. We're approaching the 80s where the Berlin Wall falls. Reagan and Gorbachev have their debates, and suddenly the USSR is no more. And now China starts to take off. Here comes Russia back up. China's in the World Trade Organization, becoming a major powerhouse. Look at those emissions grow. Oh my gosh, we have a winner, but look at third place. If we just go a little into the future, India is right behind. Isn't that exciting? Well, it provides a way for me to begin the discussion about climate change. And one of the challenges of climate change is controlling greenhouse gas emissions. It's an enormous challenge because it's so linked to economic growth. That growth in China that we saw pulled millions, hundreds of millions of people out of poverty. And so we need to begin the discussion about climate change and the system assignment. I'll give you my allocations in a little bit, but we need to begin this discussion about climate change by thinking about the moral issues of pulling people out of poverty with economic development. Access to affordable energy, reliable energy, is the first step on the rung of economic development. It's an absolutely essential quality of life. Yet about 1 billion people do not have access to electricity. Another 2 billion people have to cook on biofuels, wood, dung, whatever. They have to gather it, they have to grow it, they have to spend an inordinate amount of time devoted to it, right? It's hindering their economic development. They're inhaling the smoke. It's a tremendous health hazard. So we have to increase the energy supply dramatically to meet the needs of the people we're pulling out of poverty, as well as the growing demand for the middle class. Our demands on energy are huge. How do we get that energy? Mostly by burning fossil fuel, which emits greenhouse gases. That's the challenge. Here's a number that really puts things in perspective. 80%. That we have to leave 80% of the fossil fuel in the ground, right? That's a lot of coal and oil and tar sand and natural gas. A lot of money that's going to be left there if we're going to meet the 2% goal, if we're going to meet the carbon budget that we have. At the same time, we are already committed to burn 80% of the greenhouse gases that will get us to the 2-degree mark, that will get us to the danger zone. We've already built power plants and bought cars and hot water heaters and other appliances and infrastructure that will burn 80% of the greenhouse gases that will push us to the 2-degree mark. And we haven't even paid for them all yet. So we're not going to replace those things until we pay for them. You're not going to get a new motorbike, a new electric motorbike or car, or a hot water heater that doesn't use fossil fuels until you've paid for the one you have. So we're committed to burn 80% of the budget already, and we still have to bring in a couple billion people into the global middle class. That's a tremendous challenge. It's also going to be a tremendous challenge not to burn the fossil fuel that's in the ground that we're going to have to leave. Right? Because that's a lot of money, a lot of political power. And here's another number that you need to know and understand. 2 degrees, or 3.6 degrees Fahrenheit. 2 degrees Celsius. We keep hearing it. What does it mean? people talk about it like it's the end of the world. No, what it means is that it's 2 degrees above pre-industrial levels. And that's significant because at that point, things become really expensive. As the economy starts to get disrupted, sea levels start to rise, coastal cities start to flood, it becomes very expensive at 2 degrees to adapt. Okay, now it's time for just a little bit of science, right? And this is the source of a lot of confusion. Greenhouse gases cause climate change because they absorb energy. They absorb heat. Heat, as you'll remember from high school biology and chemistry, is just really stuff moving around, right? And so when the rays from the sun come through the atmosphere, they actually pass right through the greenhouse gases. They bounce off the earth, they change color, they become infrared, they change the wavelength, and then they start to reflect back out. And it's then when they go through the methane or the carbon dioxide or the water vapor that those things start to move. It speeds up those water molecules. And the methane ones shake a whole lot, right? They're a whole bunch more heat absorbing. And those things bump into things, and that's what heat is, right? So the more of those molecules we have in the air, the more they're going to heat up, the more heat there's going to be generated, and going to bounce into other things and create change. Here's a figure that I like because it shows the relationship between the concentration of greenhouse gases, or CO2 equivalent, and temperature. Right. So this is from the Stern Review. It's a bit dated, 2006, so the numbers are probably a little bit more precise now, but this is still a great diagram to understand the relationship between how much of the greenhouse gas is in the air and what's the projected temperature. And you can see there at 2 degrees, the projected concentration would be 450 parts per million. We're well above 400 now, so we're well on our way to that 450, maybe 550. It's hard to know. Right. So this diagram I also like because it shows the confidence interval. The little barbells there suggest at either end that's sort of the 90-95% confidence interval, what we think the range is. Where the line is suggests what the best prediction, the best estimate is. So this graph illustrates both the relationship between concentration of greenhouse gases and temperature, and the uncertainty of these estimates and why perhaps they're a bit contested. And here's another informative diagram that shows where the greenhouse gases are coming from. You can see carbon dioxide, CO2, is by far the most with over 80%. Methane at 10% and maybe rising because of fugitive gases, but and it's a concern because it's so much more of a potent greenhouse gases. Nitrous oxide from farming and fluoridated gases from refrigeration, what have you. We can also see how it's broken out by what sector of the economy, whether it's generation of electricity or driving or manufacturing things or growing our food. And it's perhaps the food might even be larger than the 9%. All right, I've got a few more graphs I want to show you. This is a fascinating one, and you might want to pause and stare at it. It's a little bit complicated, but let me talk you through it. This on the left side is where the greenhouse gases are coming from, and you can see there the light blue, the 288 parts per million. That's the pre-industrial. That's back at the beginning of the race that we started this session off with. That's before we started burning coal or anything. That was the amount of carbon dioxide equivalent in the atmosphere. And we put in 92 parts per million of coal, that's the brown, and then the black is the oil and natural gas, and then cement and steel, other big sources of greenhouse gas emissions. And the land use would be deforestation, right? And reducing and losing all the carbon out of the soil. So that's the left side of the graph. Now the right side of the graph, where it starts with green, is where where the carbon's getting reabsorbed. So some of it's going back into the land. Trees are growing, plants are growing, soil is absorbing carbon dioxide. Soil has one of the biggest sinks of soil in the world. So does the ocean, right? And massive amount of carbon has been absorbed by the ocean, and it's starting to turn it a bit acidic. And then the atmosphere is the balance, right? That's where most of it is, and that's why the amount of carbon dioxide has increased in the atmosphere. So this is a great graph for looking at the sources and the sinks of carbon dioxide. Okay, bear with me. I only have a few more figures and equations to show you before I get to my allocations. And I know that's why you came here, hear the logic behind my allocations. But I think if you get these basic relationships down, you really have a great understanding of climate. And here is we start to switch to what we're going to do about the climate change challenge. This is the mitigation challenge. And so here's a map, what's called the production gap between sort of the pledges of what countries are saying they're going to do and where we need to be in order to stay below the dangerous either 1.5 or 2 degree temperature increase. The red line at the very top is what people seem to be doing now. These are the plans and projections that people say they're going to do, and you can see that its temperature is going to rise as a result of that. Concentrations are going to rise. If the brown line, the one next to it, that's the one that was agreed to in 2015 by the Paris Pledge, right? That's what people said they're going to do in order to meet that pledge. So we're not quite meeting our pledge yet. Now the green line with the band, the third line down, that's what it's going to take to get to 2 degrees Celsius. So you can see even the pledges aren't going to get us there. And then to be super safe at 1.5 degrees, that's the purplish line at the very bottom. That's what it's going to take to get there. So this is the production gap. This is the gap between what we want to do, what we need to do in order to stay safe and affordable in that 2 degree to 1.5 degree range, and what we're currently pledged to do, right? Now here is a formula that I find incredibly useful for informing my decisions about how to go about mitigating climate change. The relationships, I guess there's 6 variables there. If we understand these 6, we've got a pretty good handle on what our choices are. P is the number of people, how many of us there are in the world, and S is how much we each consume. These are very difficult things to manage. P is going to be managed through the demographic transition. We've already talked about it. That's going to population is stabilizing, if not declining. But it's basically really a difficult ask for a sustainability officer to say, let's not make babies. So that's a hard number to change. So I'm not going to suggest we change it. S is wealth, is prosperity. It's the services that each person consumes. Now, I do think it might be fair to ask that we reduce conspicuous consumption, but there's, as I said before, a couple billion people moving into the middle class and a billion or so moving out of poverty. They're going to consume a lot more. And so it's a very difficult ask to say, sorry, you cannot have a flush toilet and a light bulb. You cannot live like we do. And so I think both P and S are sort of off the table, if you will. So let's focus on E and GHG. Because here we could have lots of room to manipulate and mitigate climate change. E is how much energy it takes to make each good or service, and greenhouse gases is whether that energy is produced in a way that releases a lot of greenhouse gases. Some energy, renewable energy, green energy, windmills and whatnot, use very little greenhouse gases, emit very little greenhouse gases per unit of energy. So if we drive either E or greenhouse gases down near zero, then the whole equation will go to zero. That's the key, right? So we need to manipulate how much energy each unit of good or service that we consume, how much energy it takes, and how much greenhouse gases are emitted per unit of energy. Land use and carbon capture are the other 2 obvious parts of this equation. The more we deforest, the more we heat up the soil, the more carbon and CO2 equivalent gets emitted into the atmosphere. And so we need to minimize land use conversion and maybe afforest. So that would be a type of carbon capture. We can carbon capture by planting trees. We can carbon capture with some mechanical means by which we're sucking carbon out of the air and turning it into something we put into the ground and fossilize, or maybe put it into our gas tanks. But there are lots of ways we can capture carbon and lots of ways we can manipulate the land so that it's not emitting carbon. So it feels like we're getting closer to a solution, or at least being able to propose one. And we've got a pretty good handle on the basics now. So you say, Bruce, it's obvious. Let's just change the energy supply. Let's just create an energy system that uses carbon neutral, carbon light, renewable green energy, right? That's the obvious solution, Bruce. Well, I need to show you one more graph just so that we can have this discussion in earnest. Hold on. Okay, this figure from the U.S. Energy Information Administration shows the energy supply in the U.S. And coal there in the gray, the really heavy carbon polluting energy, is getting smaller. It's 13% now. It shrinks a little bit every year, mostly being replaced by natural gas. You see, petroleum mostly goes to transportation. It's a huge slug. Renewable energy is 11%. And solar, wood, hydroelectric, and it's growing fast, but not growing fast enough. But as it grows, it's going to make all the other wedges smaller, which is going to reduce the greenhouse gas emissions. That's a good thing. But this is the U.S., a relatively mature energy system, where the demand might actually be decreasing because of increasing efficiencies as people buy greener buildings and switch out their light bulbs and change the things that they buy so that there's less energy consumption. In the developing world, where there are billions of people moving into the global middle class and there are 1 billion people or so still moving out of poverty, there's going to be an increased demand for energy. And that increase in demand is going to exceed perhaps even the most wildly optimistic growth projections for the renewables. So the renewables might be able to keep up with that increasing demand, but we'll still need energy supplied from the fossil fuels to meet the existing demand. That's the dilemma. Okay, I guess it's time for me to defend my allocations, beginning with environmental justice, climate justice. This is a tough issue for me. I'm really sad I didn't put more money. I used to have more money in this allocation. It's such an important topic. Basically, the issue is that the people who are suffering the most from climate change, the saltwater intrusion into their wells, the lost agricultural productivity, the heat strokes, the disease vectors, those are the most poor and vulnerable people in the world, right? They're being the most impacted and have the least capacity to respond. Those of us in the developed world who basically caused the problem by building our economy, emitting lots of greenhouse gases from fossil fuels, we can turn on the air conditioning, get out of the heat. Our price spikes in food don't impact us nearly as much, and we've got better medical systems to deal with disease. So the wealthy people who caused the problem are not as impacted by climate change. So the environmental justice movement the climate justice movement is an attempt to transfer some technology and capacity, adaptive capacity, to the developing world. So that they can adapt, and also to transfer some mitigation technology and capacity so that they can build their economy with an energy system that doesn't put out so much greenhouse gases using carbon light fuels. As you might imagine, this is a deeply political issue because it involves transfer of wealth and technology. That redistributive politics, it can get pretty nasty. So the developing world is requesting some assistance, and the developed world is reluctant to give too much. There are hundreds of billions of dollars that are pledged in the Conference of Parties, in the COPs that the United Nations runs to try to get consensus on what to do about climate. Much less allocated, probably much more needs to be pledged and allocated to be fair. But that's a decision that we have to make collectively. All right, mitigation through energy conservation. This is the E in the previous equation we looked at, how much energy it takes to make a given product or drive a mile or whatever it is. And so we drive that down. In the past, I haven't put much money in here because innovation has been so fabulous. Light bulbs are becoming more efficient. Green buildings are using less energy. We're cleaning water and manufacturing steel and cement using less energy. Lots of advances. There's actually money to be made there. So I thought the economy, the market competition pressures would drive this. But I'm now thinking because we probably have to flip the whole infrastructure to change the grid, change the way cars are fueled, maybe with hydrogen or electricity or whatever, that's going to require some investment. It's going to require maybe changing the building codes so that it forces the latest and greatest energy conservation techniques of buildings, because buildings can actually be energy neutral. They can actually put energy back into the grid. And so we could through some regulation and some innovation, I think we can speed and hasten the decreasing the E in that equation and driving that overall equation to zero. So this is, I put more money in here, and this requires both innovation and regulation. Okay, how about mitigation with alternative energy? This is changing the greenhouse gas emissions per unit of energy in the Bill Gates equation that we were looking at earlier. And again, I've put a lot of money, more than in the past. This is the challenge of creating a grid that has enough supply to meet the base load. And unfortunately, the sun doesn't shine sometimes, so solar power doesn't work. The wind doesn't always blow some places, so that wind power doesn't work. So we either need a grid that connects the world, a large grid, so there's wind and sun somewhere, or we need some battery technology that has amazing capacity to store and quickly put back in the grid, or we need some base load like nuclear or some other technological innovation. So this is going to require both some coordination and regulation in order to improve the grid, as well as significant technological innovation and scaling up of that innovation. So I've put more money here as well. Well, here's the big one for me, mitigating climate change by putting a price. I think this is the most powerful thing we can do, the biggest lever we can pull to change the whole system, because if we put a price on carbon, it filters through the whole system. It will change everybody's behavior. Those of us that use energy will use less of it if it costs more, and we'll be motivating people who can create carbon neutral or carbon light fuel to produce that fuel, because they'll be rewarded. They won't have the same amount of tax. There are two main mechanisms by which this could happen. One is cap and trade. So you put a cap on how much power plants or cement plants or fleets emit, how much greenhouse gases they emit. And if you are an inefficient producer of your crop or cement or building, you pay more. You pay for that excess. If you're a really efficient producer and you don't require as much greenhouse gases, then you've saved some, and you could sell that savings. You can trade it to the people that win in excess, and that's a market mechanism that incentivizes people to become real efficient and produce less because they can make some money by trading, and penalizes the people who are inefficient. Is also, we just have a carbon tax. That might be the most efficient way to do it. You just put a tax on carbon as it comes out of the ground. It might be cement. It might be oil, coal, natural gas, whatever it is. And then that price would filter all the way through the system. That would require a little bit less of a government regulatory system to do. So, of course, one of the challenges we face when we're putting a price on carbon is that you can only do that within a nation unless you have some kind of international agreement, which has proved difficult. And that's because the challenge is because there's a lot of trade in carbon. There's this virtual carbon emissions. You can see there's so many goods and products that the U.S. consumes coming from China that we're not actually emitting the carbon in the U.S. It's being emitted by the coal-fired power plants and the oil and the production of our goods and services in China. So we're in essence importing carbon emissions virtually. Somehow we have to account for this if we're going to effectively price carbon in a way that influences climate change. This issue of pricing carbon is deeply political. I really think it's one of the reasons why climate change is so controversial. And as I said, if you're really very conservative, Republican, pro-market, you're going to be opposed to anything that damages the market and requires a large government intervention and redistributes wealth in some way that's unfair. And tax and regulation, these are all bad things. But let me share with you a conservative policy put forward by a number of people in the Republican Party, Bob Ingalls included, and the Citizens Climate Lobby would be a place to go find out information about this. The slide's kind of complicated, but let me just talk you through it. The idea is it's a border-adjusted carbon tax. So there's a tax on carbon as it comes out of the ground in your country. Right, and so it filters through the whole system and drives down carbon emissions as a result, just like pricing carbon. The other thing would be is if there are goods coming in, you're importing goods from other countries, there would be a border adjusted. You'd tax, in essence, be a tariff based upon how much carbon is in that good and service that hasn't been taxed at the country of origin. And that money would be redistributed. So there'd be a dividend of some sort that wouldn't maybe replace income tax. And it wouldn't hurt local economies because local businesses wouldn't be penalized unfairly relative to other countries, businesses in other countries that don't have a carbon tax. And the argument is that if the U.S. imposes this, and then so that changes our economy, and we start imposing this tariff or this border-adjusted tax on goods coming from China, then we've dramatically increasing the price of those goods, and Beijing is going to look at this and say, hey, why are we giving that money to Washington, D.C.? We'll tax it in our own country, and we'll use that money for our own needs, and then they will have a carbon tax, and so we won't put the tariff on it. And then if U.S. does it and China does it, everybody will do it as well. So it could flip the system. This border-adjusted, revenue-neutral carbon tax is a very intriguing policy that meets the need of conservative, pro-business, pro-market strategies. Offsets. Okay, Bruce, you finally took a stand, put no money in this. Even though personally I have put money in offsets. So when I fly internationally and take students to see sustainability professionals around the world, it requires burning a tremendous amount of fuel. Jets burn, I think it's like 1 gallon a second, these big jets. I mean, it's one of the most energy intensive activities that we engage in. So I've paid for trees to be planted that would absorb the carbon, or I've supported solar power plants that will replace coal. The reason why I don't think this is worth it, us investing in it as a society, is because of leakage. That is, the trees are going to fall down, the carbon will escape, the solar plant would have been built anyways, and so I'm not using the money as effectively. So carbon capture is something I've steadily increased my investments in, because over the last few years I haven't seen a model, a prediction of how we're going to get below 2 degrees, or better yet to 1.5 degrees Celsius rise above pre-industrial levels, that doesn't include a lot of carbon capture. That there's really not a scenario out there that suggests we can do it any other way. And so we're going to have to be removing a lot of carbon from the atmosphere. We can do that by planting trees, afforestation. We can do it by some mechanical or chemical means that sucks it out of the smokestacks, or it just sucks it right out of the air, and then we bury it in the ground so it stays there. It fossilizes or crystallizes some way, and so it's permanent. This is going to require a lot of investment on the technology side and a lot of scaling up. Now, there are some really cool things going on, like mechanical chemical means of sucking it out of the air and turning it into gasoline, and in essence we can just use it again without having, we can power our cars and airplanes without having to use fossil fuels. That would be great, and it would pay for itself. The technology isn't quite there yet at the scale, so it's going to take some investment. Climate adaptation. This is my big investment. I've already hinted previously that I think we're well on our way past 2 degrees. That seems like the development scenario. And things are going to get really expensive as a result. Cities will have to retreat from sea level rise. Infrastructure will have to harden to deal with the higher temperatures and more flooding. Agriculture will have to figure out a way to produce the food supply when weather is variable, when frosts are different, when planting is different, when there are droughts and heavy storms. The medical system will have to adjust to heat stroke and new disease vectors. There's just an enormous amount of adaptation that's required, and it's going to be really expensive. It's going to require us to change the way we do business with supply chains and governance and everything. And so the sooner we get started, the better. And many of the adaptation suggestions, fortunately, if we adapt to climate change, it looks like we can also address water and food and poverty and lots of other things as well. So there's some benefits if we do it well and we do it soon. Geoengineering, changing the whole biosphere. This is a bit risky. I have not put any money in it in the past, but I'm wondering now if we at least need to study and better understand it. We do. Absolutely. These are techniques of putting things out in space that block some percentage of the solar load coming into the atmosphere, or maybe putting aerosols, sulfates or something in the upper atmosphere, and that also blocks solar load, just like emissions from volcanoes would do. We could paint our roofs white. We could re-engineer the ocean so that they somehow absorb more carbon. There are various things we can do. The problem is that they're sort of global in scale, and if we get them wrong, we might not be able to recover from them. But the reason why I'm suggesting we study this is because there's increasing talk of unilateral action. That is, one country who's very dependent upon a monsoon or a rain or something for agriculture might act in some ways to manage and change the weather system. And if they get it wrong, if they cause the monsoon to affect another country, or if a hurricane slams into a country that wouldn't otherwise have happened, then it's like an act of war. I mean, or it could be. Anyways, the liability is very uncertain. So I think we need to at least begin to look at some of the policy issues. There's some fascinating work going on, and I put those references in the assignment. Okay, I've been at this for a while this morning. This good old solar energy is coming in the window. Let's wrap up. If I had this, I used to just put money into those big three: justice, mitigation with price, and adaptation. Those are the three biggies. I still think they are. The other issues require investment, however, and I'm curious to see what allocations you come up with and what reasons you provide when you defend them in the system assignment that you'll be handing in soon. Just remember the big conundrum here, the 80%, that we are committed already to burn 80% or thereabouts of the fossil fuels that will get us to the 2-degree mark, where things become pretty expensive. And to avoid that scenario, it means we're going to have to leave about 80% of the wealth, of the carbon wealth, in the ground, of the coal and oil and gas, which of course is a big political challenge. It's hard to leave that money in the ground. So we face a huge issue here with climate change. It's related to everything else: agriculture, water, poverty. It's perhaps the existential challenge we face. But there are strategies, there are solutions, though, and they require leadership. Look forward to seeing what you do. Thank you.